Hello everyone. So welcome to the fourth video in the series of videos on superposition theorem, and in this we are solving this problem, and the playlist is available with the title superposition theorem, and there are more other problems also, so please refer to that, but for this we will be solving this particular problem, and at the end you will also find links for the third problem and the fifth problem, so you can keep browsing across the problems. Okay, so with that let's continue. Now if you're already aware of superposition theorem, then have a look at the question. The objective is to find the power consumed by the 9 ohm resistance, so you can solve it yourself, or if you want to follow through with me, you can find you can follow with this, or you can pause and get your answers and compare your answers with my answers. So let's get started. So again, superposition theorem. So consider one source at a time. So now I am considering 18 volts source. Okay, considering 18 volts source. In such case, the current source has to be open circuited. So we open circuit this and then do the problem. So the problem will be like this: 10 ohms, and then I have 2 ohms here, and then 18 volts here, 6 ohms here, and this is open circuited, and then 9 ohms here. Now immediately it becomes very simple. So 9 plus 6 is series combination, so that will be 15 volts. That is in parallel with 10 ohms, and we have a 2 ohms in series with that parallel combination. Okay, so if I further simplify this, the circuit is something like this. So I have a 18 volt source. To this 18 volt source there is a 2 ohms resistance, then there is the 15 ohms resistance and 10 ohms resistance, and then finally the circuit is completed. So these two are exactly the same circuit. So just here I have written it in such a way that it is easy to see what is going on. So 9 plus 6 is 15 in parallel with 10, that is in series with 2. So 9 plus 6 is 15 parallel with 10, that is series with 2, and connected to the 18 volt source. So what is the effective resistance? Effective resistance is 10 parallel 15 plus 2. Okay, so let me do that. So 10 parallel 15 is 10 into 15 divided by 10 plus 15, that is 25. So I'm getting 6 plus 2. So I'm getting 8 ohms. Okay, so the effective resistance is 8 ohms. So the total current will be V by R. Okay, so 18 by 8. Okay, so 18 by 8 is my total current. 2.25 amperes. Okay, so 2.25 amperes. Now here current division is happening. I am interested in the current in this particular branch. Okay. So I got this total current of 2.25. Now I need to find the current in the 15 branch. So again, current division principle. So I1 equal to, so I will call this as I1. Okay. So I1 is nothing but 2.25 multiplied by 15 divided by 25. I'm sorry, multiplied by 10, the opposite branch, divided by 25. So this will give me multiplied by 10 divided by 25. I'm getting exactly 0.9 amperes. So this is the current flowing in the 9 ohms resistance because of the 18 volt battery. Now let's continue. Now consider only the 4 ampere source. Consider 4 ampere source. So when I do this, so then I have 10 ohms here, then I have 2 ohms here. So here the battery got short circuited, the 18 volts got short circuited. Then I have 6 ohms here, and then 4 amperes here, and then 9 ohms here. So here if you look at this circuit, so 10 and 2 are in parallel in series with 6. That whole branch is in parallel with 9. Okay, so here I don't even have to find the effective resistance. I just want to find the resistance of this particular side. Okay, so let's call it RL, the left side part. So that is 10 plus 10 parallel 2 and plus 6. Okay, so what is that? So 10 into 2 divided by 10 plus 2. So that is 10 into 2 divided by 12. So that is 1.666, 1.6666 plus 6. Okay, so that is so 7.66667 ohms. Okay, so I got this resistance. Now this resistance will be one branch and the other branch is 9. So now 4 amperes is flowing. So simply if I want now I2. So again notice the direction also again will be downwards here. So I2. So now I2 will be this 4 total current, because the current division. So here the current is 4 amperes. Okay. So that 4 amperes current is divided into 2 branches. So multiplied by opposite branch, that is 7.66667 divided by the total. Okay, so 9 plus 7.66667. Okay, so this is a simple calculation to get I2. Okay, so let me do that. So 4 into 7.66667 divided by 9 plus 7 is 16. So 16.66667. So I'll be getting some current like this, 1.84 okay, amperes. So 1.84 amperes of current I'm getting I2. So then the step is simple. I need to find the total current. Okay, so I in 9 ohms is I1 plus I2. So that is 0.9. We got 0.9 here. Okay, so plus 1.84. So that is plus 0.9. 2.74 amperes. Now if you look at the question actually, so here it is asking compute the power consumed by the 9 ohm resistor. So usually students make a mistake here. So they, after finding the current, they stop here. So they lose 1 mark or something for the final step of actually finding the power. Okay, so what is the power in 9 ohm resistance? Power is I square R. Okay, so I square R. So that is 2.74 square multiplied by 9. Okay, so that is 2.74 into 2.74 into 9. So I'm getting 6.757. Sorry, 67.57. Okay, 67.57 watts. Okay, so this is the final answer for this particular question. Okay. So this is how we use superposition theorem to find the answer. I hope again you like this series. So I'm making a series of problems on superposition theorem, and the 5th problem we are going to solve this one. This is again a very conceptually simple problem, but there is some concept I want to explain in this. So this you will see in the next video in this particular series. So for now, thanks for watching. Please press the like button and subscribe to my channel and refer this to your friends. Thank you.